Welcome back to our channel. In this video, we will be talking about the much talked about IPCC report released recently. The video will cover what the report talks about energy systems. The first question is why we should focus on the energy system. The reasons are that the global energy system is the largest source of carbon emissions, and hence the energy sector is very important from the point of view of climate change. Global energy sector emissions continue to grow but at a decreasing rate. Primary sources of energy are oil, coal and natural gas. In the future, solar, biomass, and wind will replace the above sources as primary sources, until and unless carbon capture and storage is actively pursued. This means the transition will result in reducing emissions from the sector. Energy is used for purposes like heating, cooling, lighting, cooking, manufacturing, and services. Let us see which energy sources contribute how much to the energy sector's carbon emissions. Coal contributes 44%, followed by natural gas, 34%, and oil, 22%. In recent years, emissions from oil have grown steeply. Now we will see which sector contributes more in carbon emissions. Electricity leads in terms of carbon emission with 36% share, followed by industry at 22%, transport which excludes aviation and shipping contributes 18%. Just to add, in the electricity sector, emissions are still rising despite rapid deployment of wind and solar power projects globally. In the transport sector, emissions still rising and petroleum remains the dominant fuel, despite advances in batteries and electric vehicles. Low-carbon energy system transition is inevitable. The viable speed and scope of a low-carbon energy system transition will depend on how well it can support sustainable development goals and other societal objectives. Energy systems are linked to a range of societal objectives, including energy access, energy justice, and energy security, air and water pollution, health, water security, food security, economic prosperity, international competitiveness, employment. While all of these are non-climatic factors, one more important factor is technological progress in low-emission technologies. We all hearing about the demand for coal phase-out, but it will happen soon. As per report, there have been initial efforts to phase out coal, but only modest declines have taken place in coal use globally since it peaked in 2013. There is regional variation in coal phase-out, which means that the coal use has declined in the OECD regions, particularly in the United States and European Union. Use is mostly flat in China. On the other side, coal use is increasing in other major developing Asian economies. Main drivers for demand of coal phase-out are stricter emission norms, cheaper renewables, and natural gas. However, there is a transition taking place in power generation. Old coal plants getting replaced with different energy sources, for example. In the United States it is being replaced by gas and renewable, in Europe, replacement by renewables mostly, and in Asia, by advanced coal plants and renewables. Major coal-consuming countries with abundant coal reserves remain far from phasing out coal. Continued coal builds, mostly in developing countries, will increase the risks of stranded assets. To limit warming to 2 degrees Celsius or below, and without new builds, existing coal plants will need to retire 10 to 25 years earlier than the historical average operating lifetime. Completing all planned projects will further reduce the viable lifetime of all plants by 5 to 10 years if warming is to be limited to 2 degrees Celsius or below. Various national and subnational governments, public and private power companies, and 17 financial institutions and pension funds have committed not to fund new coal or coal-based infrastructure. Does this mean we are going to have an all-out transition to solar and wind power? Solar and wind energy have grown dramatically, but global shares remain low relative to other sources. Both sources contribute just 8% in terms of total global electricity generation in the year 2019. Up from 5% in 2015. Since 2015, the cost of solar PV has declined by over 60%. Offshore wind costs have fallen by 32%, and onshore wind costs have fallen by 23%. Asia dominates in terms of installed solar and wind capacity, which are 56% and 41% respectively, followed by Europe, 24% and 31%. Other sources are also contributing to energy transition. Low-carbon energy sources such as nuclear, hydropower, bioenergy, geothermal, marine, and fossil or bioenergy with carbon capture, utilization, and sequestration have continued to grow since 2015. Hydroelectric and nuclear shares in global total electricity generation remained around 16% and 10%, respectively. Bioenergy accounted for 2.4% of electricity generation in 2019. In total, low and zero-carbon electricity generation technologies produced 37% of global electricity in 2019. Battery is also going to play a major role in transition, which is supported by rapid price decline in the last decade and its application being enhanced to energy storage and electrification of the transport sector. Now, we will understand the impact of climate change on energy supply. Regionally, climate change impacts on electricity generation could be significant. Climate change impacts on bioenergy potentials are more uncertain because of uncertainties associated with the crop response to climate change, future water availability, and crop deployment. Climate change can reduce the efficiency of thermal power generation and increase the risk of power plant shutdowns during droughts. The potential additional cooling water needs of carbon capture and storage can increase these risks. Let us first see the impact on hydropower. High latitudes in the northern hemisphere are anticipated to experience increased runoff and hydropower potential. For other regions, studies find both increasing and decreasing runoff and hydropower potential. More precipitation means more water availability and hence, more hydropower production. Increased precipitation intensity may impact the integrity of dam structures and affect power production by increasing debris accumulation and vegetation growth. It also results in the silting of the reservoirs or increases the amount of water spilt, resulting in erosion. Higher air temperatures can result in more surface evaporation, less water storage, and loss of equipment efficiency. Climate change may alter the demands for water use by other sectors that often rely on stored water in multipurpose reservoirs and may therefore generate conflicts over water use. Higher temperatures increase glacier melt, increasing water availability for hydropower while the glaciers exist. Changes in the timing of snow and ice melt may require upgrading in storage capacity and adaptation of the hydropower plant management for fully exploiting the increase in water availability. Next we move to see the impact on wind power. Long-term global wind energy resources are not expected to substantially change in future climate scenarios. Changing wind variability may have a small to modest impact on backup energy and storage needs. Some studies suggest that consistent shifts in the geographic position of atmospheric jets in high-emission scenarios would decrease wind power potentials across the northern hemisphere mid-latitudes and increase wind potentials across the tropics and the southern hemisphere. Now we will understand the impact on solar power. Dimming and brightening in certain regions is possible, which will be driven by cloud, aerosol, and water vapor trends. Also, the increase in surface temperature, which affects all regions, decreases solar power output by reducing the PV panel efficiency. Increase in solar insolation is possible, resulting in increased solar output. Increases in aerosols would reduce the solar resource available and add to maintenance costs. How climate change impacts bioenergy is next. Climate change can affect biomass resource potential directly, via changes in the suitable range, i.e., the area where bioenergy crops can grow, and/or changes in yield, and indirectly, through changes in land availability. Increases in carbon dioxide concentration increase biomass yield. Climate changes, example temperature, precipitation, etc., can either increase or decrease the yield and suitable range. The effect of climate change on bioenergy crop yields will vary across regions and feedstock. However, in general, yields will decline in low latitudes and increase in high latitudes. Finally, we will see the impact on thermal power plants. Changes in ambient temperature have relatively small impacts on coal-fired and nuclear power plants, Rankine cycle. However, gas-fired power plants, depending on Brayton or combined cycle, may have their thermal efficiency and power output significantly decreased. Droughts decrease potential cooling water for thermal power plants and increase the probability of water outlet temperatures exceeding regulatory limits, leading to lower production or even shutdowns. Carbon capture may increase cooling water usage significantly, especially in retrofits, with up to 50% increase in water usage for coal-fired power plants globally, depending on the carbon capture and storage technology. Now, we will understand the impact of climate change on energy consumption. Climate change will decrease heating demands, especially in cold regions, and it will increase cooling demands, especially in warm regions. Peak load may increase more than energy consumption, and the changing spatial and temporal load patterns can impact transmission and needs for storage, demand-side management, and peak generating capacity. The overall effects of climate change on building energy consumption are regionally dependent. Moving forward, we will see impact of climate change on electricity system vulnerability. Extreme weather and storms threaten the electricity system in different ways, affecting system resilience, reliability, and adequacy. High wind speeds will result in mechanical failure or cause lines to collide, causing transient events, damage electricity system infrastructures, including utility-scale wind and solar PV plants. Lightning will cause wildfires or common mode faults on electricity systems associated with vegetation falling on power substations or overhead lines. In addition, snow and icing cause weighing overhead power lines down beyond their mechanical limits, leading to collapse and cascading outages. Snow can also lead to flashovers on lines due to wet snow accumulation on insulators, and snow and ice can impact wind turbines. Flooding, coastal flooding and rising sea levels will result in causing threat of inundating low-lying substations and underground cables. Temperature increases will influence electricity load profiles and electricity generation, as well as potentially impact supporting information and communication infrastructure, cause solar heat faults, affect system adequacy by reducing electric transmission capacity, simultaneously increasing peak load due to increased air conditioning needs. Now, let us understand impact of renewable generation on climate change. Solar energy will alter local and regional climate, like change in surface characteristics, and affect air temperature. At local scale, large solar farms cause rise in nighttime air temp in rural areas. Rooftop solar provides cooling effect in urban settings. However, it will result in reduced magnitude of impact at regional scale. Wind energy will result in change in surface temperature at local scale mainly, which can be said as a warming effect. In case of hydropower, there is GHG emissions from organic matter decomposition when the carbon cycle is altered by the flooding of reservoir, decreases over time, depends on surrounding land properties and the area inundated by the reservoir. Hope you got a complete idea on the need to focus on the energy system from the point of view of climate change, inevitable energy transition that is taking place globally, impact of climate change on the energy system, and even the impact of the energy system on climate change aspects. Comment below to tell us how you liked it and what could be the topic for the next video. Like and share the video. Also subscribe to the channel to see more such videos in future.